Good morning, good afternoon, good evening, everybody who is joining us from different parts of the world today. Welcome to the second edition of CrateDB Workshop. This time, we are organizing workshop in 2 days. The first session is taking place now, and we'll cover mostly fundamental topics around CrateDB. And tomorrow we are also organizing another session about more advanced topics. And it will also take approximately 2 hours as of today, and it will start at exactly the same time, 2 p.m. Central European times. So let me introduce hosts for today. So my name is Marija Selakovic, and I work as a developer advocate at CrateDB. And I have a great pleasure to deliver this session with Niklas and Ernan, who are working at CrateDB as a solution engineers and who are going to present a lot of technical aspects and getting started topics around CrateDB. So our agenda for today looks relatively simple, but it's filled with many interesting stuff. I would invite you to follow the whole modules for today. In total, it's going to last around 2 hours. The first module will cover some introductory stuff around CrateDB and its architecture. And then we will make a break of 10 minutes. Then we will talk more about installing and configuring CrateDB, and Niklas is going to show us a lot of useful practices to follow when working with CrateDB. Then we will have another break of 10 minutes. And finally, Ernan is going to show us many interesting capabilities and features of CrateDB when it comes to inserting and querying data. And he's also going to do a lot of demos for today. So as a part of each module, we will, of course, have a short Q&A session. But for all the questions that we don't manage to answer during each module, we will move them to the final Q&A. So approximately, we should finish for today by 4 p.m. Central European time. And if it's really necessary, we will stay longer to answer all the questions you might have. So a few housekeeping rules, not to forget. If you have any questions at any point, please don't hesitate to ask and use the Zoom Q&A function to do this. So as I already mentioned, at the end of each module, we will answer the questions that you asked for that module. And yeah, if there are some questions left, we will do this at the end of today's session. So we will make a break between each module so that you can better plan which module you want to attend. My warm recommendation for all of you today is to attend all 3. And at the end of today's session, we will share the recordings with all the attendees. So even if you don't have time to attend everything, no worries, you will have a recording after today's session. So let's start with the module 1. Module 1 is going to cover introduction to CrateDB, and we will start with explaining what the CrateDB is. So simply speaking, CrateDB is an open source distributed SQL database that is designed for handling large volumes of data in real time. CrateDB has been under active development since 10 years ago, and it's open source today under Apache License 2.0. So anybody who has interest into digging into CrateDB code and contributing to CrateDB can do so, and every contribution is warmly welcomed. CrateDB as a database is used very often in use cases that require handling large volumes of data in real time. And most of the use cases we have seen so far include time series analytics, IoT analytics, log management, monitoring, and many other different use cases where large volumes of data is actually essential. So before we go into more details about CrateDB features, let's first have a close look about how companies today actually approach the development of some new applications, especially data-driven applications. So this application can be anything from a user application, recommendation system, some sort of dashboard. And when we usually start developing a new thing, we start with a relatively limited set of data because we need to start with something, and at the beginning we don't have all the data we would like to integrate to our application. And very often the solution for this is to start with some relational database, because these are the databases you're very familiar with. We can use SQL to manipulate them. But as the system grows, as the data grows, then we figure out that we need actually to add some more features, and we need to add capabilities to handle different types of data. For example, at some point we will need to store document data or geodata or even time series data. And maybe at some point you also need some effective system to search over your data. So maybe there is a need for a search engine. And then with the importance of the AI in today's application development, maybe we figure out we actually need vector support because we want to get some insights of our data, and we want, for example, to generate text embeddings, and we need another type of data storage to store them. So essentially, at some point, we can figure out that we have a lot of different technologies that we need to integrate in one system, which makes some of the ordinary operations, such as deployment, monitoring, or operations particularly challenging. And with these different technologies and different languages that we need to use to manipulate these technologies, we also figure out, okay, now we need different types of resources. So we need multiple skill sets, we need more people. Then changing such a system becomes very hard and very costly. Total cost of ownership, of course, increases over time. So essentially, we are in some situations where making any additional changes is becoming a very, very difficult task. And this is like the general situations that we must all agree that we see a lot recently. So what we want to show you is that with the CrateDB, you can really address these challenges that I just talked about. So, and how CrateDB actually addresses these challenges? First, it offers a multi-model approach. So you can store all types of data in CrateDB, including time series data, geospatial data, document data, binary objects. And from the next CrateDB release, 5.5, that is taking place in the next few weeks, you will also be able to store a vector data. And important to mention, all these data are accessible via standard SQL by data consumers. Then CrateDB also supports evolving data structures by dynamic schemas. So as your data grow or the structure of your data go, you can actually leverage dynamic schema capabilities to address these challenges. And accept plenty of the built-in functions that could be used for different analytics tasks. CrateDB also supports a user-defined function, so you can define additional logic on top of what already exists. This is all backed up by the distributed execution engine that actually supports high-volume concurrent reads and writes. And the CrateDB leverages a lot of advanced indexing data structures, and you are going to learn about indexing tomorrow. We will cover this topic. And also CrateDB leverages columnar storage, so that means that all data manipulations such as aggregation, sorting, grouping are actually very, very fast in CrateDB. So distributed nature of CrateDB and shared native architecture also allows for a very high availability and horizontal scalability. So, and at the end, you can deploy CrateDB on the edge, on your data centers, on premise, or like in a public cloud. And synchronization mechanism that is built in CrateDB allows good synchronization between different CrateDB clusters deployed in different deployment environments. So at the end, we can see that with the one system, we can address the challenges we've talked about, and this system actually allows us to boost developer productivity, to reduce total cost of ownership, to even reduce the footprint, because we can better utilize hardware than it was the case in the previous slide. And of course, the development and changes are much easier because you don't have to deal with so many different integrations and different systems altogether that rely on different technologies. So now that you get a good understanding about what CrateDB is capable for, let's go into more deep dive explanation of what type of features CrateDB supports. So CrateDB follows standard compatible SQL syntax. And in CrateDB, you can find more or less all standard SQL features such as joins, aggregations, indexing, subqueries. There are also possibility to define your own functions, views as well. But there is also a support for full text search. So like, and soon to be added vector search. So these two types of searches could be combined even together for a better search capabilities. Then SQL, with the SQL, you can also write geospatial queries. You can query JSON objects as well. And of course, blob data. So like, CrateDB has a full capability with the SQL interface. So more or less all the things that you're used to do, you can do actually in CrateDB as well. And on top of that, CrateDB implements Postgres file protocol and dialect. So which means you can use CrateDB with many tools that are compatible with Postgres. Most of the open source tools, such as Apache Airflow or Apache Superset or dbeaver or Grafana, they make a very good combination with the CrateDB. So you can do a lot of analytics tasks with these open source technologies, which is something we are very proud of at this point. And of course, to support evolving data structures, CrateDB has a lot of beautiful NoSQL features that makes it easy to store data for various data sources. It allows for flexible data models. You can also store both structured and semi-structured data. You can store data in JSON format, not only in the relational format. CrateDB also leverages columnar store we just talked about, so for fast aggregation, sorting, and grouping. And on top of this, we have this beauty of horizontal scaling and high availability that is kind of built in CrateDB. So, but before actually someone starts thinking about using a distributed database for its own applications, it's important to understand what are the benefits of going for a distributed database as part of the overall infrastructure. And sometimes, of course, there are challenges to this, but benefits usually are very important to consider if you, for example, need very performant systems. So distributed database definitely affects overall system performance, increases the availability, scalability, fault tolerance, gives certain level of flexibility because you can scale and downscale your system based on your own needs, and it's also cost effective. Of course, there's some challenges that is more complex to maintain, but in general, depending on the use case, the benefits are very important to understand before actually choosing a distributed database to work with. And CrateDB, of course, supports all of this, has all of these benefits. But what is also very unique and very interesting about CrateDB, which makes it a quite good solution for most of the use cases we have seen these days, is that it's a distributed system built on shared nothing architecture. What does it mean? Shared nothing architecture actually means that every node in a system is considered equal and can take over any kind of task within the cluster. So this makes the maintenance of the distributed database much easier, because like you can scale the system by just adding new node. There is no single point of failure. If one node crashes, the other nodes will take over the remaining data. And essentially, there are no hierarchies between nodes. Actually, every node can take any single task. And shards in general are automatically balanced across node. CrateDB tries to do its best when balancing shards across nodes. So which means that there is really high level of availability already built in design of CrateDB. But now when we think about a single node, let's see what is the low-level architecture of a single CrateDB node and how does it work. So CrateDB node communicates with the clients through Postgres wire protocol or HTTP endpoint. And once the request or the query is essentially received by the CrateDB node, it goes first to the parser. That parses a SQL statement, creates ASD. Then the next step is to do semantic processing of the statement, type verification, normalization. And then once analyzer finishes its job, the planner actually creates execution plan and applies a lot of optimizations in order to generate very efficient execution plans. And these topics about how planner and optimizer work together, we will cover tomorrow in the second session of this workshop. Finally, this query engine executes the plan in the cluster and returns data back and returns the result back to client. Important to mention, CrateDB leverages Lucene storage. It also has support for the blob storage. And tomorrow you will also learn what type of indexes are supported by CrateDB and how they can be leveraged actually for fast querying and data analysis. The next topic I would like to discuss is how the availability is built into CrateDB. So understanding how this works is important because it gives you a better sense of how CrateDB handles some unexpected situations in the cluster, for example, failures. So if this happens, and for example, node leaves, CrateDB by default keeps a copy of all data in another node, so that if one node becomes unavailable for any reason, CrateDB can continue serving all the workloads, including also ingesting data and querying data. So the data are available, but it will take maybe some time, and this is maybe like seconds, maybe even 1 minute, until the new node joins the network, and automatic synchronization rebalancing is done, and at some point the data will become fully replicated and available again. So, but this means that even if something happens in the cluster, you will not lose the data, and you will not actually even notice that this self-healing process is underway, which is actually a pretty cool feature. So CrateDB doesn't require 24/7 monitoring. So like the very exceptional situations where someone needs manually to intervene, because this high availability feature is usually done in a fully automated way. And some of the key use cases to consider before actually choosing CrateDB as your database solution. CrateDB is a general purpose database, covers a huge variety of the use cases. What we have seen so far with our clients is that it has been used a lot for all real-time analytics tasks, for example, and IoT monitoring as well. And there is also increasing usage for application backend, for example, for streaming tasks or like gaming tasks. CrateDB can be a very, very good solution. So before I finish for today, I would like also to recap about some of the main features of CrateDB and when to consider using CrateDB. So CrateDB is an excellent solution for real-time analytics on large streams of semi-structured data or structured data. So for all time series use cases, real-time analytics, application analytics, Internet of Things, if you need full text search capabilities, if you want to support geospatial data, different deployment options, including on-prem, in cloud, event tracking. So like this is just some small subset of like CrateDB capabilities. And it's also important to have in mind that besides all these great features, there are also some technical characteristics that you also need to consider before choosing CrateDB as your storage solution. So in general, CrateDB follows eventual consistency model. So for all types of queries, except on primary key lookups, only in this case, CrateDB follows a strong consistency model. So lookups on primary keys are strongly consistent, and for all other types of queries, it's eventually consistent. And of course, CrateDB favors the normalized data models, being a distributed system. If you need very highly normalized schemas, maybe CrateDB is not the best option in that case. But in general, for most of the use cases, CrateDB can be a very good storage solution due to its multi-model approach and SQL capabilities and NoSQL capabilities as well. So thank you for listening to this first module. I would like to discuss the questions that we have. I see currently there are like 2 questions in the Q&A. The first one is, does CrateDB use Elasticsearch in the background? The answer is no. CrateDB is actually built on top of Apache Lucene project. And that's the similarity to Elasticsearch, because Elasticsearch is also based on Apache Lucene project, but the query engine is definitely very different to Elasticsearch. If you have any concrete other questions in this regard, just please ask it. Do all needs to be equal when it comes to hardware? There can be mixed setups. There could be mixed setups. You can use, for example, some nodes for hot, some nodes for cold storage. That could be mixed setups when it comes also to geographical locations. So essentially, the answer is in general no. The nodes don't need to be equal when it comes to hardware and deployment. So do you want to share some of the insights from IoT use cases or real-time analytics? I think this workshop is more or less designed to give you some sort of overview about CrateDB capabilities, but we would be very happy to essentially discuss some specific use case with you in a separate call. So to save time on our side for today, yeah, I would like to invite you actually to discuss the use case in some of the separate calls. let's say they have a time series that has 1 million points per minute. One of the labels allows lookup in a table with 30,000 reference data records. So I need to denormalize CrateDB efficient enough for joining this query. So performance of join is essentially always a moving target. And I would say in this situation, the join can be very efficient because it actually requires joining two tables. When you require joining multiple tables, then you need to think how the join actually operates in the background, how the execution plan looks like. And we will talk about some of the very good performance tips when it comes to join operations in the tomorrow's session. So thank you for this very interesting question.